In this video, I am going to set up a linear programming application problem. So, like with most application problems, the first thing that we need to do is determine what it is that we're looking for, which means we need to identify the nature of our variables. And sometimes it's easiest to go to the very end of the problem. So here it says the weekly advertisement budget is $22,200. How many advertisements should run in each of the three types of media to maximize the total audience? So we're maximizing total audience, and we have three different types of media. So what are those different types of media? It appears that we have television, newspaper, and radio. So I'm going to let X equal TV, Y be equal to the newspaper, and let Z be equal to the radio. All right, so those are the three different types of media. We want to maximize the total audience. So what do we know about the audience? Well, now let's go back up to the beginning. It says, according to market analysts, television will cost $3,000 per advertisement and reach 90,000 people. Newspaper costs $900 and will reach 42,000 people. Radio costs $700 and will reach 12,000 people. So it looks like what we want to maximize is P is going to be equal to 90,000 for 90,000 people are going to see each TV ad, so multiply that by X, the number of TV ads. And then we are going to have 42,000 people for each ad, so that would be times Y. And so remember, these are the numbers. The number of TV ads, the number of newspaper ads, the number of radio ads. And then finally, each radio ad will reach 12,000 people, so 12,000 times Z. So there is my objective function. That's what I want to maximize. Now, what about the constraints? So now this is where we have to read very, very carefully as we're going through these problems. Let's change to green. So what is one of our constraints here? So going back to the top, it says, according to market analysts, television will cost $3,000 per advertisement. So I would say that sounds like 3,000 times an X. And then newspaper will cost $900 per advertisement. That sounds to me like a 900 times Y. And that radio will cost $700 times Z. Well, if this is going to be a constraint, we need to know what it's going to be less than, equal to, or greater than. So that's when we go down here and it says the weekly advertising budget is $22,200. Now we know this is a linear programming problem. Our constraints have to have inequalities. The question is, and this is extremely important, do we have less than or equal to or greater than or equal to in every single constraint? Because the way that we solve it will be dictated by the nature of the inequalities in the constraints. So if the budget is $22,200, we could spend less than the budget. We could spend equal to the budget, but we can't spend more than that's in the budget. So that would be less than or equal to $22,200. And that looks like a constraint. Well, what else do we have here? So that pretty much takes care of the first couple lines. The newspaper limits the number of weekly advertisements from a single company to 12. So the newspaper, which is Y, limits the number of ads to 12. So once again, we could have less than 12. We could have 12, but we can't have more than 12. So Y would have to be less than or equal to 12. There's another constraint. In order to balance the advertising among the three types of media, the number of radio announcements, which is Z, should be no more than. Now, no more than means less than or equal to 3 times the number of TV and newspaper ads, 3 times the number of X plus Y. So X plus Y would be the number of television and newspaper ads. 3 times that would be 3 times the quantity X plus Y. So Z has to be less than or equal to that. And then finally, it says, okay, and the total number of ads should be less than 50. There we go, I was looking for that. The total number of ads should be less than 50. All right, so if the total number of ads is going to be less than 50, that means the TV ads plus the newspaper ads plus the radio ads has to be less than or equal to 50. And I believe that would be it for our constraints. So we determined what the objective function was. And again, go to the end of the problem, determine what it is we're looking for, identify what your variables are, get the objective function down. Then start looking at your constraints and read very, very, very carefully. Now, the last thing that I want to say about this is what type of a problem is this going to be? So it looks like all my inequality symbols are less than or equal to. Now, of course, we're going to have to rearrange this a little bit. So what we're going to have to do with that, of course, is say, well, Z is less than or equal to 3x plus 3y, or negative 3x minus 3y plus Z is less than or equal to 0. That's the way we would want to write that. But the important thing is all of the inequalities are less than or equal to, and we are trying to maximize. So this would be a standard maximization problem, a standard max problem, which means you have to go back and say, okay, how do I set up a standard max problem? And then you take it from there. All right, I hope this was helpful. Have fun.